Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our studies on how to calculate for minimum sample size needed for an estimation. So this is the formula for the minimum sample size needed for an estimation, particularly for the population mean. In some instances, maybe you want to go out to collect a data for you to use that data for your analysis. But first, you have to know the number of sample that we are going to use in order to help you to estimate for the population mean in your event. So here, for you to be able to calculate for the sample, you have to for you to be able to calculate for your sample, this is the formula for you to be able to calculate for your n, right? So here our n is equal to z subscript alpha divided by 2 times sigma square all over e raised to the power square. But how did these people came about this formula? Yes, so during our studies in confidence interval for large sample, we learned something. Let's visit to our worksheet and then prove how they got this formula, because it's very, very useful for you to know. So as I was saying, when we are treating the confidence interval, we saw that our margin of error E is equal to z subscript alpha divided by 2 times our population standard deviation divided by square root of n. So we have these two. We have this equation. We just want to make this n here the subject. If we will be able to make n the subject, then we have to multiply both sides by n, so that this n will cancel that n, and then we will be getting e times square root of n, which is equal to z subscript alpha divided by 2 times population standard deviation, right? So this is what we will have. So since we want n, right, not e times square root of n, we have to just divide both sides by e. That's the margin of error, to remove the margin of error from the n, and also remove the square root from there. So if you want to remove the square root, just square both sides. Once you square both sides, we are going to get our n, which is equal to z square subscript alpha divided by 2 times the population standard deviation square divided by the margin of error square, of which you can write the same thing as this, right? So this is how they were able to give us our n to be z subscript alpha divided by 2 times the population standard deviation divided by our margin of error. So since you have been able to note this one, let's go and solve some work example. So question 1, a scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From a previous study, the standard deviation of the depth measure was 4.38 feet, right? So this is the question being given to us. We have been asked to estimate the average depth of the river. We want to measure the depth of the river, right? So the depth of the river too is n. We have to calculate for our n, right? And then we know that our n in the formula is n is equal to z subscript alpha divided by 2 times population standard deviation divided by our margin of error. And then population standard deviation was given inside the question, right? Our population standard deviation, please, I'm coming. Our population standard deviation was given inside the question as 4.38. And then our z subscript alpha divided by 2. Our confidence interval was given as what? 99. And then in my previous video, I taught you how to calculate for the confidence intervals. How to calculate for z subscript alpha divided by 2 when our confidence intervals is given to you. So when you visit that video, you will see that 99% confidence level, our z subscript alpha divided by 2 will be given as 2.58, right? And then our e here is given inside the question to be 2. That is, he wants to be 99% confidence that the estimate is accurate within 2 feet, right? So that's what our margin of error, which is 2, right? So once we have this one, we have our sigma, we have our z subscript alpha over 2, we have our e, the work is done, right? So here our n will be equal to z subscript alpha divided by 2, which is 2.58. As you can see, they have written it here, times the population standard deviation, which is 4.38, as it is written here, and our e is 2. Once you times it and divide it and square, we are going to get 31.92. 31.92. So that is our n. So since our n cannot be in decimal, you just have to run it to get what? 32, right? So here our n, which is the sample size, will be what? 32, right? So our next question is saying that a pizza shop owner wishes to find the 90% confidence intervals of the true mean cost of a large plain pizza. How long should the sample be if he should wish to be accurate within 0.15? A previous study shows that the standard deviation of the price was 0.26, right? So right now we have our standard deviation, our population standard deviation, to be 0.226, and then we have our z alpha divided by 2 to be, since we are on 90% confidence interval, it will be 1.65, right? Please, if you haven't watched that video on how to calculate this one, please kindly go back and watch it for you to really understand it before coming to solve minimum sample size for the population mean. And then we have our e to be given as what? 0.15, right? So once we have this one, this is our formula, right? Just substitute our z subscript alpha divided by 2 times our population standard deviation times our error margin, and we are going to have this one. So 1.65 times 0.226 divided by 0.15 all squared. We are getting 8.18, right, as our answer. And as I said, we cannot leave our n in decimal light. We have to just run it to the nearest whole number, and we are going to get 9. Sorry, if we run it to the nearest whole number, we are going to get we are going to get 8, right? I'm going to get 8. So that is how the sample size calculation is being done. So please kindly take your time and then watch the video very carefully, so for you to really understand. Please, if you are new to this channel, please kindly make sure you subscribe, like and share, so that this video will also get to your friend. Thank you for watching. Bye. Have a great day.